Map is a very useful function for scaling data. So map allows you to take an input in a particular range that you specify here and then map it to another range. Now you might want to map something like the position of the mouse to a frequency range, for instance, and that's possible. So let's take a look at this. So here's the map example. I'll show you the example working. Here's the mouse value in the X range, and it's scaled up to a value between 0 and 1. That's also called normalizing data if it's between 0 and 1. So here we have the code that's being used. Basically we get the mouse X value and we use the text command to write that to the screen in a particular position. And then we use the map command to scale the mouse X value between 0 and width minus 1, 0 and 1. So this is the input value, 0 and width minus 1 would be the mouse X values that you'd actually get from mouse X. And that's what we're passing in here. So that's the normal range, and we want it to go into a different range between 0 and 1. So that's happening here. That goes into scaled mouse X, and then the text command writes that value to the screen in a different location to the mouse X value. So let's just run that again. This is extremely useful because you'll have to do a lot of scaling of your values to get them into sensible ranges all over the time. And if you use mathematics to do it, it can be very arduous and annoying. So the map command is really handy. Some other data formats. There's extensible markup language and JavaScript object notation. JSON is the new version of XML. It's less strict. XML is very strict but very complex and annoying. So for more on this, go and watch this video here. So there's an important thing to recognize about these formats. They're tree-like formats. So XML is often you have a node which breaks out into multiple nodes, and each of those has information and then more nodes, and it's a tree. The other format for complex data is a matrix. So you can have a matrix made up of rows and columns. So there's only really two formats for data that is complex. If you ignore the types of data like character and other types like numbers and floats, etc., then thinking about the shape of data, you have two main formats. Lists, which includes lists of multiple values, which are matrices, and trees, where everything is connected to a base node. So don't get too confused about this. Most of the time you will, if you're doing data visualization, you'll want matrices, most of the time. Sometimes you'll want trees. JavaScript object notation can show a matrix as a tree, and then you can convert it back into a matrix. This will become clearer when we get to when you use Twitter for J or something like that. So another way of loading data is just by looking at a simple text file. Here we have some data from Apple's stock price, and we want to load it in as a set of lines. We can use split string to access individual variables by splitting the line on a comma, for instance. So let's have a look at this data. So if I go to read data, this one here, you can read the data in and have a look at the information and see how many entries there are. So I'll show you the button first, and you can see down the bottom here we have data loaded 252 entries. The minimum value is 192 and the maximum is up 325. So let's have a look at that file. I'll go back to read data and look at the data folder, and in there is the Apple stock file, and we'll have a quick look at that. So you can see these are comma separated values. You've got 1, 4, 2010, 213.43, 214.50, 214.01, and then 1763320. So you'll notice that if I scroll down, every row has the same number of columns. So this is a matrix. We have how many rows? 252. How many columns? 1, 2, 3, 4, 5, 6, 7. Now if one column had an extra, one of the rows had an extra column, it could get very confusing, because what do you do with the rest of the data, the rest of the rows? Do you add an extra column for those? It's really important that our data has the same format, so we have the same number of columns for as many rows as we like. Alright, so let's look at the code. We set up the window, set up smooth, then we read the data into lines, which is an array of strings. So each row is a string, and then we can say how many lines are there, and that's how long the data set is, how many rows. And then we pass the data by using a loop here that steps through the lines and splits the lines on the comma. So each of those rows is split up into pieces. Each row will be 7 different pieces split on the comma. Now, make sure you don't have extra commas in the rows, like the strings that have commas in them, because that will cause confusion. And here we're getting the fifth, or actually the sixth value in that list. Remember, an array starts with 0. So this is an array. Pieces, sixth value, we add that into an array called price, which has the same length as the number of rows. We've set that up here, and we initialized it, or we declared it up the top here. Then we go println length entries, and we determine the max price and the min price for the closing price, and we print those out as well. And that's the end of the process. So running it one more time, there we go, same detail. So to display the data, let's have a look at that. We're going to have to work out how to print it to the screen. So here's display data. Do the same thing, but this time we draw the graph. You can see here, draw graph, price, min price, max price, and the draw graph code is here. Draw Y labels and draw X labels. Now this is a good start for some code if you want to actually do the same thing but use different types of data. So here's the data. These are the 252 numbers drawn as a line over months, and this is for 2010. So month 1 is January through to month 12 is December, and you can see the end of December is there. So take a careful look at this one. It's pretty straightforward. There's some drawing code here with the vertex command that you know well now. Got a begin shape and an end shape, and then drawing based on mapping that information into an appropriate range. X1 and X2, Y2 and Y1. So have a look into that. This is another example of a matrix. We have a matrix that has information about each of these nuts. Head shape is pan, minor diameter tolerance, nominal diameter, thread pitch, price, available yes or no, number in stock, flat or Phillips head, or both. So some of these variables are numbers. Some are numbers, but they have a letter attached to them. That letter G should actually be up here in brackets, and this should just be the number. These are just numbers. These are kind of categories, names for these types of things. Although the names refer to the diameter, of course. These are categories, so you can have either a pan or a round or a button. These are numbers. Perhaps this dollar sign should be here again in brackets, and these should just be straight numbers. Yes or no, true or false, numbers again, and categories again. So this is a matrix. Notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9 variables, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 rows. That's a matrix. So here we can load that table using load table, and we can load applestock.csv with a header row. Now this is really quite nice. Let's have a look at that. So here's the table example. Here's my CSV file. I'll take a quick look at this. So I'll show you through this very quickly. Office is complaining at me for no good reason, and it's happy now. Good. So you can see this is what you get if you look at a CSV file in Excel. You see, in this case, we have names for each of the variables. You can see month, day, year, low, high, close. So during the day, stocks will trade for a low value and a high value, and then there'll be a close value that they close at. And the volume is the amount of stock that has traded. So some days there'll be lots of trading, some days not very much. And you can see a wide change in that. Basically, we can look through the data fairly quickly and see what's going on. If you just look at this using a text file, we'll see what we saw before, but with the header row here. This is the header row, by the way. Then we see commas between each of the important variables. So looking at the table here, quite a bit of data. We're going to run that, and we're going to get the same type of thing here. This red line I'll come back to soon. But you can see price, month, source, etc. But the data has been loaded in a slightly different way. We've loaded a table. We haven't just loaded lines and then split them up one by one. We've loaded a whole table from a CSV file, including a header, and now we can just fairly easily pull out information from the table using the table methods like get row count, rows, get float, get int, etc., etc. from the rows of the table row here. Now this is a for loop in a different form. We say for table row colon my table.rows, that's the number of rows, and we step through each of the rows in my table. Now here's the draw details here. You might want to see this moving average code. That's what creates the red line. We take in the data, we specify the minimum and the maximum, and then we look at the data by taking an average over time. So we look at a number of data points over the last however many periods, and we take an average. That's called a moving average, and it moves forward with the average dropping a number in the past and adding to the future, etc. You can see draw Y labels and draw X labels as well. That's pretty straightforward.